Games are made of a lot of parts, and Collision is certainly one of them. The first mainstream game ever made, Pong, has 2 paddles and a ball. If the ball hits the paddle, it bounces. If the ball hits the end of the screen, a player gets a point. This was revolutionary stuff, and it is also just Collision in a trench coat, maybe a moustache, a monocle, perhaps. The point is, you would certainly notice it if it were missing. But how does this all-important system for games work? For this example, we'll be using a screenshot from Totally Real Quest 3, A Twist in Time. It shows our plucky hero, an arrowy shot, and a goblin whose day is rapidly going downhill. And they are having a blast of a time, but now we need to figure out what has hit what. So how do we do this? For the simplest approach, we could check if the drawn pixels overlap each other. After all, everything here is pixels. The hero is pixels, the arrow is pixels, the goblin is pixels, and so is its corpse! However, as soon as you get to this level of gameplay, you'll run into some performance issues. This is overcomplicated, unoptimized, inelegant, and just bad. In fact, all of those words just mean bad when you boil it down, so this approach is bad. Let's try something else. Thinking a bit bigger than pixels, what other famous shape has 4 sides? That's right, the rectangle. Let me tell you, out of all geometric shapes, rectangles are a solid S tier. Their collisions are the cheapest for your CPU to check, computation-wise, and they can cover almost anything. Heroes, boulders, subtitles you were trying to read. Thank you, Disney Plus. Now if only there was some way to see just what that French meant. Well, this will definitely work, and it'll work fast, but despite how S tier they are, rectangles aren't the best for everything. Oh, it's okay, champ. Look, you're still number 1 for me. Look at the screenshot again. This doesn't take place in the void, but in a world, and this world, too, needs to have collisions. And if you try to make your level geometry out of rectangles, your game isn't going to feel great. Adding in different kinds of shape, like lines, circles, and polygons, all help with this. While they will bring in some more complicated maths, there are guides out there that will tell you all the checks you need to do, so you don't even need to worry about that. All you need to know is that checking collisions between lines is slightly more expensive than a rectangle check. And a polygon needs to be broken down into multiple lines and checks done for each of them. So checking a 5-sided polygon against a rectangle is more than 20 times worse than just rectangle against rectangle. Your spot in the top is secure, dude. So we now have our shapes, and we need to check if this line arrow is intersecting our polygonal goblin. And we will need to do this every single frame. This is inelegant and not particularly optimized. If you refer to the science from earlier, this is bad. Still better than bad, but we can do better. How do we do better, you ask? Well, the answer's obvious. More rectangles. Honestly, rectangles are just the best. I was invited to their wedding. A swell guy all around. We can put a rectangle around our polygon and line. Now we can check if they roughly collide, and we only have to do the complicated maths if there's a high probability of them fully overlapping. If a cheap rectangle check rules that out, we can end things there. We now have a solution pretty close to optimal, and our totally real game Quest 3 is running smoothly. But let's look at our screenshot again. Under our current system, we still need the arrow to check against the goblin, the river, and each one of these trees and boulders every single frame. For just a few rectangle checks, it's all good, but with more projectiles and a larger world, these numbers will add up. So how do we solve this? You can probably see this coming at this point. More rectangles! They are hands down peak geometric performance. A rectangle pulled me from a train wreck once. I owe them my life. The method we're going to break out is called the quad tree. The idea is simple. Our level can be split into 4 rectangles, and then these 4 into 4, and so on for as many divisions as you like. For each collider, you make your way down these levels, seeing which root cell it ends up in. Then when you want to check for collisions, you only have to check in the root cells that shape is already in. It may seem counterintuitive to add in more collisions to take away collisions, but let's just check our example to see that it works. With just 3 divisions, we can rule out many more objects with more expensive shapes than just rectangles. And quartering the game world each time is very efficient. In a huge world like Skyrim or Breath of the Wild, for example, taking maybe 5 collisions to rule out thousands of collision meshes would be a godsend. There are always more little tweaks you can add on top of it. For example, in most games, if you put a cliff down, chances are it'll be there when you walk back to it, so you might as well permanently bake it into the quadtree, rather than re-adding it every single frame. But for now, the hero can finally kill that goblin. Off screen, of course, I don't want my channel taken down, and my tablet can't draw red anyway. Now you know more about how collision works, at least on a 2D scale. When you see stuff like this in the future, just remember, the developers didn't use enough rectangles. See you in the next video.